Professor Izrat Karnan with the mechanics, Q.K.GHORI. Okay, let's see here. Today we are discussing the example of the chapter number 8 of Q.K.GHORI. Find the distance traveled by the particle moving in a straight line. Find the distance traveled by the particle moving in a straight line with constant acceleration a. It means the particle is moving with constant acceleration a in the nth unit of time. Nth unit of time. What does it mean? Okay, you have to find the distance traveled by the particle during the nth unit of time. Okay, I give you example here. For example, if someone say that some particle is moving along the straight line with a constant acceleration a, and you have to find out the distance traveled by the particle during just 7 seconds. Just 7 seconds. Then what do you have to do? You will do this thing. That you will find the distance traveled by the particle during, just see here, 1, 2, 3, 4, 5, 6, 7. 7 seconds. You will find the distance traveled by the particle during the 7 seconds. This will be like this. This will be the distance. Let's say I call it x1. Okay. Then you will find the distance traveled by the particle during the 6 seconds. This will be the particle, this one. Basically, you want to find out the distance traveled by the particle during just 7 seconds. You want to find out this distance. And what will be this distance? This distance will be x1 minus x2. It means our required distance will be x1 minus x2. I hope so you got a point here. Now, if you want to find out distance traveled by the particle with a constant acceleration a in the nth unit of time, it means first you will find the distance traveled by the particle during n seconds. Then you will find the distance traveled by the particle during n minus 1 seconds. This will be the during n seconds, and then you will subtract this from this x1 minus x2. This will be the time just during nth second. I hope so you got a point here. It means, okay, I'm going towards now its solution. We have a solution. What I'm saying here, let x1 and x2 be the distance traveled during x1, x2 will be the distance traveled during n seconds and n minus 1 seconds. As earlier, I give you the example that x1 will be the distance during n seconds, x2 will be the distance during n minus 1 seconds. Then our required distance will be respectively. Then what I say? Then distance traveled. Then distance traveled during just nth second. Just nth unit second will be, okay, what will be this one? It will be x1 minus x2. x1 minus x2. I explain you these things, that if x1 is a distance during n seconds, x2 is a distance during n minus 1 second, just during nth second, this will be x1 minus x2. Just nth second. During nth second, what will be the distance? We want to find out those things. Okay, we'll start here. No issue. Okay, we know the second equation of motion. Okay, we know that x is equal to ut plus half at square. We know this is the third equation of motion. Okay, what I'm doing, first of all, I'm finding x1 distance during n seconds. Okay, what I'm saying here, for t equal to n seconds, x will be x1 here. So I can put here, rather than x, I can take here x1, u, t will be n here, because I'm calculating this distance during n seconds. plus half a, and it will be n square. Now what I'm doing? I'm finding a distance x2 and that will be during n minus 1 second. So I'm saying here for t equal n minus 1 seconds, you know x will be x2 here. So what I will do here I will place x2 u rather than t, I can place here n minus 1 plus half a. Rather than t here, I can place n minus 1 square. So now, I can call it equation 1. I can call it equation 2. You know already, our required distance is x1 minus x2. So what I can say here, that required distance, if I want to find out the required distance, that will be x1 minus x2. Okay, first of all, write down the x1 here. And what is x1? It is un plus half an square. Here is minus, and it will be u into n minus 1 plus half a into n minus 1 its square, and this mode close. Okay, now what I can do here, this I can multiply this minus as well here. This minus you can multiply here. This will be un plus half an square minus u into n minus 1. This minus will come here, minus 1 by 2a, and it will be n minus 1 whole square. Okay, what you can do here, this will be un plus this half an square minus u. I can multiply here, it will be un minus minus plus, it will be u plus half a. Here I can expand the formula of n minus 1 whole square. It will be n square plus, I hope so it was the minus sign. Yes, it was the minus, n square plus 1 minus 2n. This bracket close. This un plus n minus will be cancelled. So you will be having this only u plus half an square minus 1 by 2. I can multiply all these things there. So what will happen here? Minus 1 by 2 an square minus 1 by 2 a, and 2 and 2 will be cancelled. Minus minus which will be plus, it will be plus a. Let's see here. This is my plus 1 by 2 an square. This is minus 1 by 2 an square. This can be cancelled. So you will be having here u plus this an and minus half a. U will be as it is. Okay, what I can do here, 1 by 2a I can take common. If I 1 by 2a can be taken common, it will be 2n minus 1. Hope so baat samajh aaye. What I have done, 1 by 2a I have taken common. If I have taken 1 by 2 here, I have to multiply 2 here. It was 2n a already I have taken, minus 1 by 2a I have taken common, it will be minus 1. So this is x1 minus x2. So you got your required distance. So what is this? This is the distance traveled by the particle during nth second. Hope so you got my point. Now I'm moving towards another example here. Now we have another example. Okay, let's see here is statement. A stone is let fall freely. Let fall freely from a height. Let fall freely from a height of 100 feet. Find the time. Find the time that it takes, and the time that it takes, and the velocity, and the velocity that it acquires on reaching the ground. On reaching the ground. Okay, my dear students, just see here. A stone is let fall from a height of 100 feet. It means let fall means you are, the particle is falling like this. Let fall. This let fall. Let fall means initial velocity will be 0. Okay, a particle is let fall here like this. Yeah. This is the particle. It is moving downward. And how much? From a height of 100 feet. It means this height is 100 feet. If it is let fall means that its initial velocity will be 0. Keep in mind, during this chapter, you have to keep in mind that whenever the particle is let fall, it means its initial velocity will be 0. Okay. So we got a point that particle is let fall. It means its initial velocity will be 0, and it has to cover the distance 100 feet because its height is 100 feet. It means I can see here that wherever its age is 100 feet. Okay. G. Keep in mind this is gravitational acceleration. Its value is 32 feet per second scale. Normally, you know its G value is 9.8, but that is in meter per second scale. Here G is 32. It's a feet per second scale. Keep in mind this thing. This is the value of G here. This is the value of G here. Another thing, the particle is moving from up to down, so G will be positive here. If the particle is moving from down to up, its G will be negative there. Okay, now G is positive. Okay. Now what do you have to do? Find the time that it takes and the velocity that it occurs on reaching. It means you have to find out final velocity and time taken that is particle take to reach from this to this. Okay. First of all, we find a final velocity. My dear students, if you want to find out the final velocity, you have initial velocity, you have a distance, you have G. You want to find out final velocity. It means you have no time yet. And whenever you want to find out the final velocity and you have no time, then you can use the third equation of motion. Because in third equation of motion, there is no time. In the first and second, there is time. Okay, now I can use by third equation of motion. Okay, what I can do, this is like this. 2ax equal u square minus v square. 2a means this G. X means this h. Because travel distance is h. U, because the particle is let fall, so its initial velocity will be 0. This will be 0 minus. Sorry, it's not u square, it's v square minus u square. V I want to find out. And because the particle is let fall, so initial velocity will be 0, so u will be 0. 2ax equal v square minus u square. V is the final velocity that I want to find out. U initial velocity, because again and again I'm telling you particle is let fall, so 2g. What is g here? It is 32. What is h here? It is 100. And this is v square. So it means your v square will be this. V square will be 6400 and it will be feet per second. But you want to find out v, you can take a square root. This will be here. You will be getting v equal to only 80 feet per second. So we got a velocity. Now I want to find out time. Keep in mind that when you want to find out the time, you have initial velocity, you have now final velocity. Initial velocity, final velocity. We have acceleration. We can use the first equation of motion. First equation of motion, very simple. Okay, by first equation of motion. Okay, you know what is first equation of motion? V is equal to u plus 80. Now you can put the values here. What is v? V, this is 80. U, it was the initial velocity. Because the particle was let fall, so its initial velocity was 0. A, G. G means it will be 32. T, you want to find 80 equal to 32 into T. You want to find out T, that will be 80 over 32. So you got 80 over 32. So it will be 5 over 2. And you can write here seconds. And you can also write this T equal to 2.5 seconds. So we got a time. Again, I'm revising this thing for you. That particle is let fall. It means its initial velocity will be 0. And it's a let fall from a height of 100 feet. Height is 100 feet. It means h is 100 feet. Because particle is moving from above to down, so g will be positive. You want to find out final velocity and time. For finding final velocity, you use a third equation of motion, 2x equal to v square minus u square. I put a equal to g, x equal to h, because x means distance traveled and particle has to cover a distance like height. Hey, okay, v, find initial velocity 0, v, you put the value, we got a v. Then we use the first equation of motion, v is equal to u plus 80. We have a final velocity, we have initial velocity already, a means g and t, and I got a t, so I got a time traveled by the particle during this journey. So I hope so you got clear everything. For the time being, bye bye. Allah Hafiz.